Okay, so in this video, I had a student ask me, all right, we've learned about matrices, and the book says you can do it by hand, so why don't we do it by hand? And it's a fair question. We used to. The calculator has come along, and so has made things a little bit easier, but just to set up a video to where, okay, well, here's a system of equations, solve it using matrices. Now, there's lots of different ways to use matrices to solve things, but primarily what I'm going to use here is called the Gaussian-Jordan Elimination method. It basically has three parts to it. So we have our system here. We're going to have to convert this into a matrix. So in order to do that, we have to take the coefficients of each piece to include this last column here. This column is called the augment. This means that this thing will form an augmented matrix. What that implies is that you will have, quote, an answer column. There are ways to use matrices that don't include an answer column per se, and therefore it's not necessary. However, when you're using matrices to solve systems of equations, you can think of this as simply a set of numbers and get rid of the letters explicitly. So this becomes 1, 2, 3, 4, 1, negative 1, negative 1, 0, 4, negative 3, 1, and 5. Now the thing to keep in mind on this is that in this new matrix format, this is the X column, this is the Y column, this is the Z column, and this is called the augment. I'm just going to put AUG. It is not August. And so in the augment column, we're going to be looking for answers. Now, there will be situations that come up where you might get zeros across one column, or you'll get zeros in the first three, but another number in the last, and those indicate issues. We have problems. In this particular matrix, we don't have problems, so it's kind of nice that way. I have gone through and done this on a calculator just so that we have an answer, and so when we solve this, the answer is going to look like this. 1, 0, 0, 1, 0, 1, 0, 0, and 0, 0, 0. Whoop. Not 0. That becomes a 1, and this is also a 1. And so our point is the point 1, 0, 1. That's the ordered triple. So that's the solution that we're going to look for. All right, well, here we go. We're allowed to do three different things. So number one, we can exchange any row. So we can exchange rows. This may come in handy if we end up with a row that we like somewhere else better. We are allowed to multiply any row by any non-zero number. And that's real numbers, by the way. And so C is a real number, not 0. And then the third thing that we are allowed to do is we are allowed to add any two rows and replace one of those rows with the sum. Okay, more often than not, you're going to stick to using a combination of 2 and 3. However, every now and then it comes around that through this process you might come up with a 1 where you would like a 0 and you see that another row has it. And we can exchange rows. For those of you looking for a little bit more in-depth analysis of matrices, I'm sorry, but you're going to have to look elsewhere, because that's all the further I'm going to go. All right, let's go ahead and get started. So I'm going to rewrite my original matrix here. Pardon me, I'm working on a new pad, which is a little bit bigger, and it takes a little getting used to. So I've got 1, 2, 3, 4, 1, negative 1, negative 1, 0, 4, negative 3, 1, and 5. Okay, here we go. My notation, by the way, is going to dictate things. I'm going to do all these calculations kind of in my head, because otherwise to use up paper would be prohibitive. These things take a lot of paper, as you may have found out using systems. Anyway, matrices actually take more. All right, my goal here, I know I'm done when I have 1, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1. That's my goal. So when I'm done, that's what I want. In other words, I would like to have zeros here. Okay, if I can get 0, 0, it's known as a triangular matrix, more specifically a lower triangular matrix. But anyway, and somebody'd have to check me on that one. It might be lower or upper. I forget exactly how it's determined. But we want to get all those to be zeros. So in order to do that, what I'm going to do is I'm going to take, and I'm putting my arrow here in the second row. The arrow will change depending on exactly who's getting changed. My second row is going to get changed. I'm basing that on if I multiply this row here by -1 and add it to the first row, I'm going to put that answer back into row 2. So row 1 plus the opposite of row 2 is going to go to row 2. Okay, so that means I'm going to multiply this second row by -1. I'm going to add row 1 and row 2 together, and that's using my third. So I'm using step 2 and step 3 together, and I'm putting that sum into row 2. Row 1 does not change, so I'm just going to write that down. Row 3 does not change, so I'm going to write that down. And now, for, you know what, I'm going to undo that. I'm going to write those in white so that you see that they're unchanged. 1, 2, 3, 4, 4, -1, -3, 1, 5. Now I take 1 times, -1 times 1 is 1 plus, or -1 plus 1 is 0, so that becomes a 0. -1 times -1 is 1 plus 2 is 3. This is 3. -1 times -1 is 1 plus 3 is 4. -1 times 0 is 0 plus 4 is 4. And so that's what my new row 2 looks like. All right, now I'm going to do the exact same thing, but I'm going to do it down to row 3. I'm going to eliminate this 4 out of row 3. And to do that, I'm going to take the -4 times R1, I'm going to add it to R3, and I'm going to put the answer in R3, so in row 3. So here we go. Rows 1 and 2 do not change, so I'm going to write those in white. 0, 3, 4, 4, and then I'll do this one in red. Okay, so now we have -4 times 1 is -4 plus 4 is 0. -4 times 2 is -8 plus -3 is -11. -4 times 3 is -12 plus 1 is -11, and -4 times 4 is -16 plus 5 is -11. All right, well, what I'm going to do there, so I'm going to make use of, I'm actually going to make use of, I think, yeah, that'll make it easier. I'm going to make use of number 2 and number 1 in these next two steps. What I'm going to do is I'm going to multiply row 3 by -1/11. Remember, I can't divide, I can only multiply. And the reason that I'm sticking this in there, and somebody says, well, it's the same as dividing. You can't actually divide matrices. You can multiply by their inverse, but you can't divide them. There's no algorithm for that, and there's no definition of it and what it would look like even if you did. And so we're going to multiply by its reciprocal, and what that's going to do is it's going to change all those -11s to 1s. And so on my next matrix here, I have 1, 2, 3, 4, 0, 3, 4, 4, and 0, 1, 1, 1. Okay. Now what I might do is, for the sake, yeah, I'm going to do it. Okay, so what I'm going to do now is I'm going to use my first rule here, and I'm going to exchange row 2 and 3. So row 2, and exchange that with row 3. And here's what that looks like. 1, 2, 3, 4. 0, 1, 1, 1, 0, 3, 4, 4. Now the reason I did that is because, remember, I want these all to be zeros down here in that lower left-hand corner, and that 3 is going to become a 0 here. I thought it would be easier to do that than to multiply by 1/3 here, because then I'd end up with fractions, and I don't really want to work with fractions. It's bad enough. All right, so now what I'm going to do is I'm going to multiply row 2 by -3, and I'm going to add that to row 3 and put the answer in row 3. So -3 times row 2 plus row 3 goes to row 3. Keep in mind again, rows 1 and 2 do not change. So 1, 2, 3, 4, 0, 1, 1, 1. And now they change. And so 0 times -3 is 0 plus 0 is 0. -3 times 1 is -3 plus 3 is 0. -3 times 1 is -3 plus 4 is 1. -3 times 1 is -3 plus 4 is 1. Okay, so now I've essentially started out here, and let's see, you know what, let's do that in dark blue. I've started out here, and I've kind of gone this way with it. And now what I'm going to do is I'm going to start here, and I'm going to go this way with it. And so I'm going to eliminate all these ones in the top as well. At this point, you have a choice. You could, in fact, stop right now, put the whole thing back into a system, because you know z is 1. That's what that bottom line says. This piece says that 1z equals 1, or z equals 1. And you can use substitution to go back up through. I'm going to continue with the elimination. And so if you want to stop the video at this point and say, okay, I've got it, no, I'm all good, then that's perfectly fine. Otherwise, yeah, continue with the video, and we'll use elimination to go back through, and we're going to eliminate that those upper 3 values. All right? So here we go. Let's go back to purple. Now, I'm going to start messing with row 2, so everything I do is going to be going here. All right, so now I'm going to take negative R3. I'm going to add that to row 2, and I'm going to put the answer into row 2. Now, what that's going to do is it's going to change this 1 here to a -1, add it to that, make a 0. Don't forget the goal. The goal is to have a 0 there. So that's why I'm making the decisions I'm making, is I want a 0 to be in that place. We're going to write down rows 1 and 3 in white because they, again, have not changed. It's very important to take copious notes whenever you're doing this, because you can easily get lost. And go back to purple. All right, so negative R3, so negative 0 plus 0 is 0. Negative 0 plus 1 is 1. Negative 1 times 1 is -1, plus 1 is 0. Negative 1 times 1 is -1, plus 1 is 0. And now you look at that second row, and that second row is exactly the way we want it. We have 1, 0, 1, 0. We're done. Whatever that fourth column is irrelevant. That just kind of follows along. So now we know that y is 0. So we're just going to continue this out. And now I'm going to start messing with that top row. And when I do that, I'm going to take, first I'm going to eliminate this 3. To do that, I'm going to use this 1. I don't want to use row 2 because that's going to put some more stuff back in. And I don't want to do that. So I'm only going to mess with the 3. So I'm going to take -3 times row 3 plus row 1. I'm going to send it to row 1. Remember, row 1 changes, everything else stays the same. So I'm going to put 0, 1, 0, 0, 0, 0, 1, 1. And then going back to green, I've got negative 3 times 0 plus 1 is 1. Negative 3 times 0 is 0 plus 2 is 2. Negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times 1 is negative 3 plus 4 is positive 1. Now I want to mess with that second column of row 1, but I don't want to do anything else. So I'm going to use my second row to mess with my first. So I'm going to take negative 2 times row 2, add it to row 1, and I'm going to put that answer into row 1. When we do this, if we've done everything right, it should come out with only what we need. I'm going to put my non-changing, whoops, that's bad. My non-changing rows back in white, and then going back to this kind of reddish color, pinkish, peachish. I'm going to go ahead and work on this first row. So negative 2 times row 2, and you do it column-wise like we have been doing. Negative 2 times 0 is 0, plus 1 is 1. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 0 plus 0 is 0. Negative 2 times 0 is 0, plus 1 is 1. And now you see, at this point, we now have the solution. And so reinterpreting this, this says that 1x plus 0y plus 0z, and 0 times anything is 0, so this is really 1x equals 1. The second row says that 1y is equal to 0. The third row says that 1z is equal to 1, and therefore our ordered triple is 1, 0, 1. Which, and I'm hoping this pops up because I'm recording this particular black screen and not all the stuff around it, which, after I've put into the matrix of the calculator and solved it, is exactly what the calculator solved it as. Now, if you can't see this calculator, just take my word for it. That's a typical row operation solution to a matrix. Most of the time, people are not going to make you do it by hand anymore because of the calculator. But if you need to, that's how you do it. And you continue in that process until you are totally complete. That's it. Bring lots of paper. Have fun with it.